Take it away, Kyler.
Yeah, it's kind of a perfect transition from Brandon to what I'm going to be talking about. I am really talking about the stage of site reliability from a point where almost nothing exists. So before I get started into that, I'll just do a brief about me because I don't have an about me slide. So I was actually born and raised and been here my whole life in Birmingham, Alabama. Growing up as a young hacker, I always just imagined that to do something cool in this industry, I'd have to leave this city and leave my home. So it's just incredibly cool to be standing up here and see all the awesome representation from all the tech companies and the people inside of Birmingham doing cool stuff. So yeah, it's a great thing for me to kind of realize. So the title origin, Bootstrapping Reliability and Performance by Building an SRE Team. Like I said, bootstrapping in the sense that when I joined Fetch in January 2020, there was 2 SRE engineers that were hired within a month prior to me joining. There was 3 or 4 DevOps engineers who were just getting started with a lot of the problems and tools needed to deploy some of these site reliability things that Brandon talked about. So I guess the point of all that is that when we approach the problem of how to prioritize performance reliability with our product, we really had to start from the ground up. I will also say I work for Fetch, and I won't talk too much about what Fetch is, but I do want to make a point of a couple of the parameters that we use to solve the problems around performance reliability. So one of the first things that I noticed when joining the company is how there was an extreme prioritization on fast feature release. And doing that, some things, corners might have been cut, and it typically involved testing in production, which I know is something that can directly go against a lot of the principles that we were there to try to solve and create a lot of the problems that we were trying to solve. So actually, there was also an extreme amount of user growth, particularly the previous 2 years leading up to the decision to create an SRE team and leading up to the decision to try to start addressing these problems in a scalable way. The Fetch app in general had started previously as something very different than what it is now. And so what you had is you had a lot of old legacy code, monolithic architectures, and those codes were being adapted in new ways. People were pulling out those certain functions from code to apply that logic into a microservice that it wasn't really built to support. And we were growing super fast. We had just made several Series C and Series D funding. We were hiring engineers like mad, and so there was a lot of new blood and new people coming in and making commits to code bases that, like I said, were either old or they had different functionality. And it really meant that we truly were starting from the very beginning. So at this point I figured okay, well, we kind of throw out the playbook, which was easy for me to do because I have 0 experience in site reliability, and therefore I knew of no playbooks to follow in order to accomplish these things. So at this point there was some overwhelming anxiety about what my role was actually going to be and how I was going to help this team achieve this. And that that's kind of the purpose of what I wanted to talk about is how I applied and how the team applied basic engineering principles to just take this very big problem and we'll get into some of those problems that we were experiencing and actually create software solutions for them. In some case, software solutions, in some case, human solutions. So my first day, I remember my first day, I'm looking around and I'm like, I really don't know where to start. So I just started digging into documentation, trying to absorb as much information as I could. I actually found this document titled Sev1's Outages and Other Big Hurts. It struck with me because I thought, I don't know if that's a typo or the person wrote it was experiencing extreme emotional distress, but I knew for sure it was a good place to start if I was looking for problems that I could help solve and for problems that the team could help solve. So this was like a giant document of all of the incidents that had occurred over the previous years. Completely unorganized. It was in a Google Sheets. There was links to Slack threads, links to documentation. Oh, and I just spent days reading through all of these incidents and trying to understand, like, what were the trends that were causing these outages and problems. And of course, a lot of the trends that I found were already being addressed by different teams. Conversion of microservices, observability improvements by the DevOps teams, deployment improvements, and things like this. So I tried to focus on things that weren't currently being addressed. Some of those trends I've listed here. I'll go through some of them just in general. The on-call process was a general on-call rotation of back-end engineers. They would spend a week on call, and then they would cycle to the back. So there would be maybe 20 weeks in between an engineer being on call and then coming back on call. So there was this very rusty feeling every time an engineer went on call. That on-call engineer had no escalation process. So if that person who had probably not worked on any of the code that they were troubleshooting could not figure out the problem, their escalation policy was just to tag someone in Slack or call them if they knew their number. And this became a problem for developers because if the developers that knew the most and who were able to solve the most problems were the ones that got called for almost every issue. So there was an extreme problem with burnout amongst our most valuable engineers. Another one that I noticed that was rough to handle was outages may go days without even being noticed. And you may say, well, how were they even noticed? And in some cases, it would be somebody just looking through metrics and realizing like something doesn't look right and it hasn't looked right for days. And that just was not helping the cause of getting these incidents resolved quickly. The other two have a lot to do with documentation, playbooks, information about the services, very little information to go off. So even when these engineers did encounter a problem, sometimes they would have great documentation and great playbooks, but in a lot of cases, they wouldn't have any. So I started to look at these things and outline that these were some of the first problems that maybe we could start to address to have the most immediate impact in improving this problem for the team. So easy solution, right? Just hire site reliability engineers, and that is certainly what we did. Of course, I wasn't a site reliability engineer, but we did hire several, and that did help to kind of address some of the big problems with observability and some of the other issues. But in general, it didn't really give us an action to get from nothing to improvement to hopefully one day a very sophisticated reliability as code platform, which is something that I knew was a great goal to shoot for and would certainly help with a lot of these scalability issues as we started to scale. So I took those problems that I found in that first document and I really started to organize them. When I say I of course mean we as the team. It's just kind of an easier technique to say I, but we as the team took those problems and we organized them into more actionable goals that we could actually start working towards. I don't have them listed here, but I'm going to just go over them in general. So one of those goals was achieve first order alerting of all of our microservice endpoints. And that was something that I wanted to specifically address that issue we talked about of incidents going days without without being noticed. Another one is that we wanted to measure our services' success as a whole. Certain services may have great Grafana dashboards. Grafana, give it my full backing as well. It's a fantastic tool, and it was something that all of the developers were using, all of the engineers were using. So in terms of how to measure that success, we really didn't have a great way. So we really built a very rudimentary tool that went out and tested all of these endpoints and stored those results into a database, and then we wrote functions and lambdas that would analyze that, that data and then return a success result. The interesting thing about what we wanted to do with the measuring the success result is we weren't simply looking to measure uptime in terms of returning successful response. I mentioned earlier some of the goals around around Fetch and what we wanted to do as a tech organization, and performance was certainly a key factor in that. So we actually implemented a penalty for performance. So if a response came back successfully but it did not meet our performance threshold, we actually counted it against us. We implemented this performance penalty in July of 2021, and about 40% of our synthetic API calls at that time were outside of the performance threshold. So in terms of 3 nines, we were reporting a number around 6 and 3 nines. 69.99% was our success rate, and that was tough to look at. But we had a fundamental belief that if you measure something and you focus on it and you report on it, that it will become a focus amongst the teams and that it will get better. So there were days where I would report this metric. We actually wrote a bot to report the metric because we felt like if it came from a human, it might hurt the culture between us and the developers. So we wrote a bot that would just paste it out there, and then when anyone had any questions or arguments, it was, well, just talk to the bot, and Seriously though, like we did have we knew that the tooling was very rudimentary, it was new, we were trying to build a culture, so we investigated and looked into all of these issues, and the basic response that we would give is like, well, trust it, look into it, something has to be wrong. It's returning, your call is taking 900 milliseconds, something is not right, so look into it, but we will also look into it as well, and then that really encouraged collaboration amongst the two teams and helped introduce us to these developers who, at that time, they had no idea what we were there to even do or what we were there to help for. So going on to the next goal, we really wanted to take over that 24/7, 365-day level 1 support. And while the end goal definitely was not to take over that support, it was something that I felt was important in this moment, because I truly believe that the way that I have always understood problems and started to create solutions for those problems is to actually experience the pain of those problems. So there were many nights where we would be on call and get these problems and get these pages, and it was a growing pain. And you may say, like, well, didn't that scare away people? And that's what I'm going to address next, is how we dealt with the fear and the overwork that came in that initial stage of taking over the level 1 support. And then the last thing we wanted to do is we wanted to build a team. I said we had 4 site reliability engineers. We couldn't do anything with 4 site reliability engineers. So we had to really figure out how to recruit people to our team. And as Brandon mentioned before, we were focusing on a philosophy around site reliability that we were a software engineering role. Like we were not there to take over. We weren't there to have an operational capacity to take over workloads for developers so that they could focus on other things. It was more about we were there to understand the problems that were causing the major performance and availability issues, and we were there to engineer a solution for them. So how did we do this? Well, we didn't turn away any infrastructure engineers, but we focused our job description specifically on software-oriented skills. We focused our interview loops on software-oriented skills and testing. But I actually don't mind the term soft skills, but we focused on soft skills as well. We focused on people who were willing to buy in, and in order to do that, we also bought into them and invested into them. So one of the questions I'd get asked a lot in the interview process is like, what is life at Fetch as an SRE? What's the day-to-day look like? And I was just honest with them that we didn't know, like we were still figuring it out, but we were investing in you, and we knew that it may be 2-3 months before you could ever become productive. It may be 2-3 months before you started to understand the problems, but once you did, you would start to engineer solutions that were smart, and engineers that would scale, and engineers that would learn from the mistakes that were being made to get to those problems in the first place. Now, the other question I got asked almost by every candidate, especially software engineers, is what about on-call? So that was another problem that I had to solve, and yeah, so there's the problem of on-call support. Nobody likes it. It's 2022. It's all about work-life balance. Work-life balance is very important. So we really tried to examine what is it about being on-call that is so awful. And we came down to two things. Well, the first thing is very simple. It's like, well, it's extra work. It's working during my family time. It's working in the middle of the night. So we made it very clear, and in fact, we made a decree, right, that if you were on call, that was your responsibility. Your projects could hold. Your projects could wait. Your weekly reports could wait. Your code reviews, your pull requests could all wait. During that time, you were on call, and you needed to prepare yourself for that call. Just because you weren't working an incident, just because you weren't being paged, doesn't mean that you weren't preparing yourself emotionally for that call. So it meant taking it very easy. It meant after every handoff, pager handoff, which is a term that does still exist, because I once, before I took a job, a few jobs ago, I was going to take a job in which they issued me a pager, and that was enough for me to not take that job. But the other part about on-call that's so scary is that fear. What if I can't solve the problem? Like, what do I do if it's 2 a.m. and I get an alarm and it's for something I don't know and I can't figure it out and the pressure is building? And I actually, my previous experience really gave me ability to understand that fear, because I had felt it before and I knew what it was. And I talk about this concept, fight or flight. I actually have the Britannica definition of fight or flight. I know everyone is familiar with it, but one of the key things I want to focus on the physical, on the Britannica definition, is the idea that it's a physical response in your body. Very helpful at certain times and in certain situations, definitely not helpful when you're trying to solve an engineering problem or trying to understand why an EC2 is crash looping, etc. So I started thinking about what are jobs where you have extremely high pressure but require an extreme understanding of your surroundings and extreme abilities to focus on the elements of that problem and what you can do and not to panic. And I couldn't help but think about airline pilots, flight engineers, right? They're 40,000 feet in the air, 600 miles an hour. There's 140 people on board. Their own lives are on board. So I started looking at how do they keep their cool? How do they handle these problems? And I really stumbled across this process. I heard it referred to as POIC, and it's a process that flight engineers follow to take the problem, address it, and to never panic, because there's always the next step. There's always the next piece. So the problem, an alarm goes off. That gives you some key starting points for the problem. Information, gather information about that problem, the services associated with the problem, the infrastructure associated with that problem. Options. You need playbooks, you need data, or you need documentation on those specific infrastructure pieces. Maybe it's not a playbook specific to that service, but maybe it's a playbook specific to the infrastructure related to it. Database playbooks. Can you apply point-in-time recovery? What are the risks of applying point-in-time recovery? Select an option, execute the option, and then evaluate the option. I want to step back from this process just for a second to understand that each one of these pieces gave us improvements and actionable items that we could make to make this process easier. For problems, it was about improving alerting. Brandon mentioned it, every alert should be actionable. So looking at alerts and understanding what should be alerted on, what shouldn't be alerted on. Looking at dashboards and anomaly detection and all of these things that would improve that problem process and remove as many unknowns as possible. Information, we talked about service mapping. We talked about tracing, or I'm talking about tracing and logs and all of the things that come with observability. How can you gather as much information, but not only gathering information, but gathering information quickly? One of the things that we did specifically about this is we implemented a service in Elasticsearch where when you use our incident tool to spin up an incident, you tag the service. The service knows which infrastructure is associated with that service. It knows which pieces of other services are involved, and then it attaches a dossier of information to that incident. So you immediately have that information. You immediately have a link for a dashboard, for documentation, for a playbook. Options, right? Working with the developers, working with chaos testing, things to generate these different options. What can you do? Testing these things, understanding, like I said, the risks around point-in-time recovery. Is this an option? Is it not an option? In terms of selection, it was more of a human thing, building confidence in our engineers, leading by example, understanding that mistakes were going to happen and that they were not detrimental, but there was something to learn from. That's how we get better at this process, as we make mistakes and we learn. Execute, tooling, right? If I'm gonna execute one of these options, I need to know how to do it. How do I log into AWS? Is it in this account or that account? How do I run this script for this piece of a database, but not for this database? All of those things were things that we could practice, that things we could improve the learning and have our engineers work on. And then evaluate. There's not much to that, but to evaluate that it actually worked. Because if it didn't work, or maybe it introduced new problems, what do I do now? Well, depending on what it does, you start back at the top. If it introduces a new problem, you go back to problem and you start going down the list again. If it doesn't solve the initial problem, you go back to options and you select a different one. Now, in the rare case that this doesn't work and nothing comes from this, we then implemented, obviously, an escalation policy, right? Attaching subject matter experts. And I told you about those back-end engineers. They were on those on-call rotations. They were burnt out, the developers. So they were excited about the process of doing this, because it put responsibility in their hands. If they were getting paged constantly because we couldn't figure out their problems, it means that there was a lack of information, there was a lack of options, or there was a fundamental problem in the way that their services were being developed and deployed. So, did it work? Well, I guess that's still to be seen, but we're 1 year into this process. I told you in July, 40% of our calls were responding over our performance threshold or responding bad in general. Today, that number is 99.03. So I would say that that's definitely an improvement, and that's definitely something that we're building the success on, but not where we want to be now. So we still have more to go. We still have more improvements to make. The incidents that would take several hours to notice, our mean time to resolution currently is 40 minutes. It wasn't tracked prior. 40 minutes is not great. We need to get that number down. Under 10 minutes is our goal. But it's a massive improvement from days, if not hours. And I will note that, like, for our Sev 1, our major incidents, this number is much lower. The synthetics P99. So the synthetics is not an accurate representation of our client experience. We understand that there's latency depending on your geography and your reception and all of the things that goes into that, but it did give us a baseline. So the baseline in July, when we really rolled out most of the stuff, was nearly 900 milliseconds. That currently today is 104 milliseconds. We're covering over 2/3 of our API endpoints now. I didn't go into the details of the first order health checks and that system because I know I'm short on time, but it is very similar to the system that Brandon described in the sense that developers define their alerting, their endpoint alerting based on their synthetic API or they check it into a YAML file, and then that YAML file is read by our monitor. One thing I will say is that we did develop a coverage monitor system that would compare what we have to what we don't have, which again gave us an actionable list of endpoints that needed to be monitored. Now that we're into the 2/3, it's a much more difficult problem because some of them are creating data and things that we need to be cautious of in terms of reporting business metric. The last metric that I'm going to report that is the one that I'm most proud of is over the last year, we hired 11 site reliability engineers. So that team grew from 4, counting myself, to 11. And currently, all 11 of those engineers still are employed, still work on the site reliability team. We don't do like employee happiness metrics, but they seem pretty damn happy to me. And we don't get a lot of complaints about on-call, and we have a belief that going on-call often and rotating that out is better than the long 1-week rotations, and that's something that where we really saw the employees' happiness around that process improve. So that's all I have. I don't anticipate any questions, but if there are, I'm happy to take them.
Do we have any questions for Kyler? Oh, got a question. Navigate the maze.
We had planned. Was there a connection with the Terminator GIFs, or were those just Terminator GIFs?
I'm sorry, I can't hear you.
The Terminator GIFs? Why were there so many Terminator GIFs?
It's just the best movie that's ever been made. And to be honest, Arnold is the most GIFable.
He'll be back. Any other questions?
How long were your rotations? I think it was.
So that's a great question because the rotation started for 1 week, and we quickly realized that what people didn't like about that is when they started their rotation, they felt like they couldn't see the end in sight. And maybe that's the startup culture, or maybe that's just the world we live in today where 7 days feels so far in the future. But it was basically just because they felt like they had to rearrange their whole week. So we changed our rotation to Monday through Friday, so a weekly rotation and then a weekend rotation. The weekly rotation ends up seeing most of the work, and then the weekend rotation is more disruptive because you're usually out doing things. So the benefits we saw was that if you were on call, you could still have weekend plans. And if you were on call for the weekend, it was just 2 days, 2 nights. So. Or 3 nights.
Cool. All right. We're going to take a quick, right around 10-minute break. Thanks, Kyler.